But we look at finding how you find zeros of a polynomial. The last section, I kind of already had things in a factored form. Now we're kind of looking at if you can't factor, what do you have to do with this? Okay, well, the first thing I want to work on a little bit here tonight is how you do long division of a rational function and how you do synthetic division. Okay, it depends on your background, how much of that you've done. So what we're doing is we're going to start by doing long division instead of synthetic and just kind of talk through that. So what we're going to do on this then is you start this problem like this. You just write down x squared plus 4x minus 45, and then we're going to divide that by x plus 9, okay? Now you may or may not remember how to do this. I'm going to write the steps on this. When you're doing this problem, you just do this in your head primarily every step. So the first thing you do is you do division. Okay, when your division algorithm, you divide. So you're doing x to the second divided by x, okay, which is what? That's x, okay, so that's your result of your division. So you're going to record that straight up like this, okay? And this is the division algorithm that's taught in this part of the world. It's taught very differently in the eastern part of the world. So the next thing we do is we multiply, okay, or times. So what we're going to do is x times x plus 9. Now I'm going to show you the steps because I want you to see that, but you don't have to write the steps down because you're going to do this in your head anyway. So if you do that, you would have positive x squared plus 9x. So you record that directly underneath. So that would be plus x squared plus 9x like that. Okay, and we're going to keep doing a certain process until we get a remainder. Okay, the third thing you do is you subtract. So what I'm doing on this is I'm subtracting this, and again, you're going to do this in your head. I'll show you the way I usually show this. You're doing x squared plus 4x, and then you're doing minus x squared plus 9x. Okay, what that does is that changes these signs. So I usually just teach students, you can either do this in your head, or you can just change those signs from plus to minus, and then you can just combine those columns. Now, like in my Calc 2, I gave Calc 2 test this morning. There was two problems they had to do long division on. They just had to because of the type of integration we were looking at. So what we would do here is that would cancel. It always will. 4 minus 9 would be negative 5x like that. I changed the signs because I'm subtracting. Does that make sense? You don't have to do that on your paper. You can subtract in your head. That's just kind of an alternative way to do that. And then step 4, what do? You bring down the next number, and that completes the loop. So you end up with the minus 45 like that. And then essentially what you got to do is you just got to start all over again. Okay, is everybody okay with what I did there? Okay, a lot of times if students haven't done this in several years, it's easy to forget how to do division. Okay, so let's continue with the next thing here. So now what we do is we start over again. Now we're going to divide these things. You just divide by x. Don't worry about the 9. So you're going to have negative 5x over x is going to be negative 5. Okay, that's step 1. Record the minus 5 above like that. Okay. Step 2, multiply. Negative 5 times x plus 9. Do that in your head. So when you do that, you're going to have negative 5x minus 45. So just record that like that. Okay. Step 3, you're going to subtract. What's going to happen if you subtract on this one? You're not going to get anything. Everything's going to cancel out. Now, you can do it this way if you want to. You could change that to plus, change that to plus. That would cancel. That would leave you 0. Okay? So that would be the process. You just go through the loop until you're done. So then what we say is this part, the x minus 5, that's called the quotient. And then the remainder on this would be just equal to 0 like that. Okay? Everybody follow that okay? You just got to get in and practice a few problems to make sure you got the hang of this. I'm going to erase some of this over here and show you one other thing. So when you do this now, you write the answer. The answer of this problem is just x minus 5. Okay, there's no remainder, so it's just x minus 5 is your answer. I want to show you one other way to do the problem. You don't have to write this down, but I want to show you one other way you could do this problem. Okay, now you can't do this on every problem though. If you look at the numerator, it turns out the numerator on this problem does factor. It would be x and x, 9 and 5, with a plus and a minus. Okay, that would cancel out. You would get the same answer. Now, if something factors, that's the way you want to do it. But if something doesn't factor, then you have no choice other than to do long division. All right, does everybody understand what I'm talking about there? Okay? All right, okay. Let's run through one more of these, and then let's work on a little bit of synthetic division. But you need to know how to do both. Okay, so let's go ahead and set this one up. You want to write down the 20x to the third minus 7x squared minus 2x plus 11. And then we're going to divide that by negative 4x plus 3. Okay, like that. Okay. Now, where do you start? You start by doing division. So we're going to divide those two things that I highlighted. You do that in your head. You're doing 20x to the third divided by negative 4x. That is negative 5x to the second. Okay, your exponent ends up going down 1 on these things when you do that. Okay. Now, the next thing you do is you multiply. So you got negative 5x squared times negative 4x plus 3. If you do that, you would have positive 20x to the third, and then minus 15. Oops, let me write that better. Minus 15x to the second. Okay. Third thing you do is you subtract. Okay, you're more than welcome to do that in your head. I'm just going to do this and continue to do this. I'm going to change that plus to minus and that minus to plus. That thing cancels, it always will. If it doesn't, you've already messed up on the problem, by the way. And then this would be negative 7 subtract negative 15. That's why we're doing that. So that would end up being plus 8 and then x to the second like that. All right, then what do? Bring down the minus 2x and you start all over again. So the fourth step is already doing that. Okay. All right, now go ahead if you haven't already done that. Go ahead and I'll give you a couple of minutes and see if you can finish that up. See if you caught on to this. So go ahead and finish it up. Anybody got a reminder yet? So the teacher can see if he's right. What'd you get? 14. I got 14. Anybody else get 14? Okay, all right. I'll put this up here. You just got to be kind of careful about your signs and your arithmetic on there and everything with the division. So the last step that I had where I got that is I ended up having, after that became a 4x plus 11, then when I multiplied, and you're doing 11 minus negative 3, so that's where the 14 comes from, okay? If you're not getting that, you need to kind of see where you're going wrong on that. So the quotient is this part. The quotient is the answer there. So what you would have is negative 5x to the second minus 2x minus 1. The remainder is the 14, so it goes like that. Now what you want to do is you want to be able to write your answer, and you write your answer like this. You just say the answer is negative 5x squared minus 2x minus 1. And you learned how to do this whenever you were in elementary school and learned how to divide. Then you say plus 14 over the divisor. So you want to learn to write your answer like that. Like in my Calc 2 students this morning when they were doing an integral on tests, they had to do this. Then they were ready to do an integral. Those of you who have had calculus in the past may know what I'm talking about by that. Now it's easy to integrate that, okay? But part of the algebra background that they had there is to make sure that they know how to do the long division, okay? Does anybody have any problem with that? Okay, all right. Synthetic division, if you haven't done that in a while, is actually a little bit easier technique to do than long division is. So I'm going to show you basically how you want to do this. I'm just going to skip down number 3, and let's go ahead and do a couple of these, and then we'll take a break here. This is probably a good breaking point here. Okay, so what we're going to do on synthetic division is really all you do is you just do the coefficients, and everything's got to be in order. You got to have a placeholder for everything. So if your highest power is fifth power, you need to make sure you have 5, 4, 3, 2, 1, 0. Okay, like that. You got to have a placeholder for everything. So what you do here is you just put the 1 down, leave a gap, and put a 7, then a 12, then a 13, and then a 16 like that. Okay? Now, this thing right here, you want to use the opposite sign. Just try to think of this like this. Just think of x plus 5 is equal to 0, x is equal to negative 5. So be sure you put that you divide by the right thing. If that was x minus 5, then you would divide by 5. Okay, yes. Am I missing something? What? I'm sorry, I'm sorry, go ahead, say it again.
There's 2 12s.
Oh, okay, good, okay, thank you. Okay, so we're all set up, okay? Now, what you do is you follow this procedure. If you haven't done this in a while, it's a real simple procedure, so just pause me if you don't see what I'm doing. First thing you always do is you bring down the 1, okay? Then you always multiply. You take 1 times negative 5. 1 times negative 5 is negative 5, okay? Then you add the column. You always add the column. So 7 added to negative 5 is 2. And you do that over and over and over again. So now you do 2 times negative 5 is negative 5. Add the column. 12 added to negative 5 is 7. Okay. Did I make, okay. 2 times negative 5 is negative 10, as I was saying. Okay, we got that. Now I add the column. What do I have? I have 2. Okay. Now I multiply. 2 times negative 5 is negative 10. Add the column, that's 2. Multiply 2 times negative 5, that's negative 10. Add the column, that's 3. 3 times negative 5 is negative 15. Add the column, that's 1. Okay, so you just bring down, multiply, add, over and over again like that. Everybody follow that okay? Okay. So what we would have then is this is the remainder. Whatever you end up at the very end, well, that's your remainder. So you'd end up having a remainder of 1. And then everything goes like this. This would really be plus 1. This would be 3x to the first is what that would be. This would be 2x to the second, 2x to the third, 2x to the fourth, and then x to the fifth. Okay, whoops, that's not right. Oh, yeah, I don't put the remainder there. Okay, so I'm not paying attention there. Yeah, when I want the remainder, we want this to go like this. This is your constant term. So this is plus 3. That is 2x to the first. Okay, that is 2x to the second. Okay, then that's 2x to the third. And then that's x to the fourth like that. Okay, that's what that represents. So that right there is your quotient. Okay, that's just x to the fourth plus 2x to the third plus 2x to the second plus 2x plus 3, and then you got your remainder like that. Okay, and what I missed when I was doing that is the remainder is really, this is an x to the 0 power, and that's just the remainder. So what you could do on this one then is once you've done that, that's a quick way to get your remainder. And what happens is that highest power just went down 1. That's the idea. If you divide x to the fifth by x, it's going to go down 1. All right, everybody with me there? Okay? All right. Okay, let's go to this next one here, then we'll take a little break here. Okay, we have x to the third minus 3. Now remember, you've got to have a placeholder for everything. You need to have x to the second, x to the first, and a constant term. So it goes like this. So you have x to the third has a 1 in front. There's not an x to the second, so what do? You got to put a 0. There's not an x to the first, put another 0. The constant term's minus 3. So that's got to go like that. The other thing you want to make sure you're solid on is what goes here. Is that going to be a 1 or a negative 1? 1. Yeah, 1. Just think of what makes that 0. 1 minus 1 is 0, okay? Then you go through the same process that we did on the last problem, but you got to make sure you have those placeholders on that. So if you bring down the 1, you'd have 1. 1 times 1 is 1. Add the column, that's 1. 1 times 1 is 1. Add the column, you get 1. 1 times 1 is 1, so you end up with negative 2. Okay, so you have a remainder of negative 2. And again, it goes like this. This right here is a constant term. That right there is x to the first. That term is x to the second. So you would end up with 1x to the second plus 1x to the first plus 1. So you just get x squared plus x plus 1 with a remainder of negative 2. And synthetic division, the thing I want to mention about synthetic division, you can only divide by x plus or minus a number. Okay, like if it's x to the second, synthetic division doesn't work. It's got to be x to the first, and if you have a number in front of that, that messes everything up. So we're just looking at x plus or minus something when we do synthetic. Otherwise, if that's not there, then you have to go to long division. That's why you got to know how to do both. Okay, does everybody understand? Okay. All right, let's go ahead and take a 10-minute break. I'll come back and we'll start doing some stuff with this as well. So I want to just graph this. You don't have to draw the graph on your notes, but I want to just have you put in this function, and let's take a look at that. All right, so let's see. We have negative 8x to the third. Okay, then we have, looks like plus 16x to the second. And then minus 8x. And we'll just start that off in a standard window. So let's get the function in. Let's just go zoom 6. Standard window, zoom number 6. Okay, I want to just kind of see what we're looking at here. Okay, all right, that's good enough. So a couple of things I want you to notice on here then is if I was to trace, like if I type trace and just put in 1/2, I could put 1 divided by 2 in, that will end up giving me that function value like that. So that's essentially what we found, is that remainder is giving you that function value. That's the idea. Guys, everybody understand that okay? All right, so that's why we call it the remainder theorem. So if I ask you to evaluate a function with the remainder theorem, I don't want you doing it this way. I want you to do it that way. That's the remainder theorem. That's just evaluating. You know you're going to get the same answer, but you want to show that you're doing synthetic division. Okay? Okay, let's do this one just with the remainder theorem. All right, so what you would do with this is on this one, we want to set up our synthetic division. So it looks like we have a third power, second power, first power, and a constant. So nothing is missing. So we have 1, -4, 3, and 5 like that. Okay, what goes in front of this thing? -2, whatever you have. Okay, don't change the sign or anything, it's just whatever you have. Okay, now go ahead and do your synthetic division. And then whatever your remainder is should be what the value of the function is. So it should give you a y value of a point on the graph. Okay, so I'll just bring the 1 down, multiply to get -2, add to get -6, multiply to give 12, add to get 15, multiply to give -30, so you got -25. If you've got all your arithmetic correct, and I have it correct, then that should be the answer. Okay, is everybody with me there? Okay, so we'd have a remainder of -25, which means that f of -2 is -25, which ultimately just means that the point -2, -25 is on the graph. Okay, that's what that is. So synthetic division is used, and it's very useful for quickly finding function values like that. Okay? All right, I'm not going to have you do anything with the graph on that. That doesn't matter. But if you put that in the graph, what you would find is you would see that you have the point -2, -25. All right? Okay, any questions about remainder theorem? Okay. All right, let's take a look at the factor theorem, and we're kind of leading up to finding zeros of polynomials is kind of the idea here. So what the factor theorem is going to say is if you synthetically divide a factor into that polynomial, what'll happen is if the remainder after synthetic division is 0, then we would say it's a factor of that polynomial, okay? So what happens on this, if it's a factor, then it just ends up being a 0. It ends up being a real, if it's a real number, it ends up being an x-intercept. So what we're going to do with this one is we're going to see if x minus 1 is a factor, okay? There's two ways to do this. I'm going to show you two ways to do this. So we have our polynomial. There's no missing terms. So you just want to put 1, negative 10, 27, negative 18. Okay, now you're checking the factor x minus 1. So what goes out in front, negative 1 or plus 1? Just 1. Okay, that's the structure. Okay, now let's do synthetic division and let's see what happens. That'll give us the answer to the problem. So if I bring down the 1, I do that. Multiply, that's 1. Add the column, that's negative 9. Multiply, that's negative 9. Add, that's 18. Multiply, that's 18. Remainder is 0. So is it a factor? It is, okay? Because it's 0, that means it's a factor, okay? Now I want to show you a way to figure this out by factoring on this problem also, all right? So what I would like you to write down is this. Just write down the polynomial x to the third minus 10x squared plus 27x minus 18 all over x minus 1. Okay, so I'm going to show you another way that you can tell this is a factor. All right. So the other thing that we have on here is let's go ahead and let's factor out. We're going to do factor by grouping here. Okay, I'll show you kind of what happens here. All right, so if I do this, if I take an x squared out of the top, then that would leave me with x minus 10, like that. Okay, I don't know why I'm even doing this. I'm off on a tangent that I don't need to be on. I just realized. Never mind. Okay, here's what's going to happen. Okay, I don't know why I was thinking this, but let me go ahead and show you what I was thinking. If you take a 9 out of this, you would end up having a 3x minus 2 like that over x minus 1. That thing actually, factor by grouping, doesn't factor into two binomials like we thought. But what basically happens is this. This is what really happens. If you did this, if you took the answer, which is x to the second minus 9x plus 18, and if you did that and multiplied that by the divisor, this is what I meant to do. I don't even know why I was doing that. So this is what I want you to do is this. We're going to take this and multiply this out. Okay, so here's why that's right. So if you take your answer, this is how you check long division. If you take that answer and multiply it by the by the answer, you would get this. So if you'd have x squared times x is x to the third, x to the second times negative 1 is negative x squared. Okay, then you just kind of go with the next thing. Negative 9x times x is negative 9x squared. Negative 9x times negative 1 is plus 9x. Okay, then finish up with the 18. You'd have plus 18x, and then 18 times negative 1 is negative 18. Okay, now that should take us back to the beginning. Okay, that's the point that I wanted to show you. Okay, so it looks like we have x to the third. The x squareds go together. Those are like terms, so that's minus 10x squared. And then, did I do that right, or did I miss something? No, I'm okay. I think I had a sign issue in here somewhere. No, I'm good. Okay, I'm good. That's 27. 27x minus 18. Okay? So it checks. Okay? I'm just trying to show you how that checks. If it's a factor, if you multiply it out, it should give you that original polynomial. Does that make sense to everybody? Okay? All right? Okay. Let's do this one. Let's do one more of these using the factor theorem. So again, what we're going to do with this one is we're going to do synthetic division. Every exponent is accounted for, so we would just go 1, negative 10, 14, and 80 like that. All right? What are you going to put in front on this one? Negative 5. Good. Okay, make sure you've got that down and don't mess that up. Okay, what are we looking for on this problem? what the remainder is. If it's 0, it is a factor. If it's not, then it can't be a factor. Okay, so we just do that. So let's see what happens. Bring down the 1, multiply, that's -5. Add the column, that's -15. Multiply, that's 75. Add that, that's 89. And you can stop. Okay, do you agree that we're not going to get 0? You don't have to go any further, okay? There's no way that thing's going to be 0. So if you get down to a point where you know that remainder is not going to work out, you don't have to waste your time doing the arithmetic. It's just too big. It isn't going to work, okay? Everybody okay with what I did on the factor theorem then, okay? All right, so what we want to do now, this was just the answers to the problems we just did. I want to kind of transition into the last part of the section. And this is what we're leading up to. Everything we've been talking about is just kind of leading up to this point. Okay, so we're going to look at a 0 of a polynomial is just an x that causes f of x to be 0. We've talked about that. And then a real 0 is going to be an x-intercept. Okay, we will talk a little bit probably in a couple of weeks about what complex number zeros are. You can have complex zeros and you can have real zeros. Real zeros are x-intercepts when you graph this, okay? So the first thing we want to show, and this stuff right here is not in your homework. Our textbook doesn't do the P over Q. I want to go ahead and go over that because I think it's worth going over. So you can find a list of potential zeros by doing what we call a P over Q list. So the idea is P is going to be that term right there. Okay, that's the 1. Q is going to be the last term like this. Okay, then I'll show you what this does, all right? I won't test you over this or anything since it's not in the book, but it is something I want you to be familiar with. Okay, so P is going to be all the factors of 1, okay, which is 1. Okay, now you can also have a plus or minus because we're also including negative factors. So the only factor of 1, remember what is a factor? A factor is numbers that go into a number. So the only number that goes into 1 is 1, okay? Then we got 24. There's a whole bunch of factors of 24. And I would do this logically. 1 and 24, 2 and 12, 3 and 8, just kind of match them up. 4 and 6, that's it, okay? But what you want to do is put a plus or minus on there. Now, if you want to put a plus or minus and then a little brace, okay, I'm okay with that. You would just go like 1, 2, 3, 4, 6, 8, 12, 24 like that. You have a plus or minus on like that. So that is your list of P and Q, and then your potential rational zeros are ratios of that number. So what you're doing is you're just taking each one of these numbers and putting them over 1. You're doing 1 over 1, which is 1. You do 2 over 1, which is 1. So if you think about that, if you form that ratio, it's just going to be those numbers in that Q list. Like that, okay? So you take ratios of all the Q's over all the P's to get all of the possible answers to the problem, okay? So that would end up being the P over Q list. Yes?
Why would you put 1 over 1 or 1 over 2?
Because if you have P,
yeah, you would put the Q on the bottom, right? It would be 1 over 1 or 1 over 2.
Oh, I did this backwards. Jeez, I'm having a bad night tonight, okay? I think I want to go home. Maybe that's what the problem is. Been a long week. Okay, it's like this. This is P. That's Q. Goes like that. It goes backwards. Okay, I have it right. It's just I wrote that thing out wrong like that. So P would be this list. Q would be that list. Okay, so I'd end up, if you want to, you can just change that to Q, change that to P like that. Okay, all right. Now what will happen is this. So I want to show you something. I want to pull up the calculator. I would like you to put this in your calculator because I want to show you something on here. And so I'm going to put in the function we have. We have x to the third. Okay, then we have minus 5x to the second. And plus 7x. And then minus 24. And let's just do that in the standard window because I want to show you something on this. Okay, so if I go zoom 6, okay, you're going to have a polynomial like we learned tonight. It's going to have that same kind of endpoint behavior that you have. And I want to zoom out on this. So what will happen on this, it won't matter on this one too much, but what ends up happening on this problem is the zeros could fall in these numbers here. They don't have to, though. If I went through and zoomed out on here, and I'm going to do that one time because this might not be that good of an example for that, but I'm going to zoom out a little bit and just see if this will make any difference here. It looks like this thing only crosses one time. Now, sometimes it can be in this list, but it doesn't have to. Okay, that's why we call them potential rational zeros. This next example might be a little bit better list then. Okay, so then what you do on this next one is you go like this. This would be the p. So p would be all the factors of 3. So what is that? 1 and 3. Okay, that's all your factors there. Okay, q is going to be all the factors of that term. So what that's going to be is that's going to be plus minus 1 and then plus minus 2 like that. Okay, then we do the p over q list. The p and q are backwards. So now if you do this, it just goes like this. You just do this in your head. You go 1 over 1, 1 over 2, 3 over 1, 3 over 2 like that. Okay, and that gives you your list like that. So if you do 1 over 1, that's 1. 1 over 2 is plus or minus 1/2. And then 3 over 1 is 3. And then 3 over 2 is 3/2 like that. Okay? So that would be, those are possible places where you could have a 0. So if you graph that on your calculator, any of those numbers could possibly show up, but they don't have to. Does that make any sense? Okay, that's why we call them potential rational zeros. Well, the only thing I wanted to show you on that is that in case it shows up, I don't think that kind of thing shows up. When I was in college algebra, which was about 1982 or something like that, we had to do these lists, and when we were finding zeros, we had to just sort of randomly pick them until we found zeros, okay? In the modern world, we just get your calculator out and find the first 0, which is what I'm going to show you how to do, okay? So we're not going to do the p over q anymore. What I want to do is now just kind of summarize and put all this together by finding the rational zeros, okay? So on this one, what we're going to go ahead and do is I went ahead and just did a graph. I was going to have you do graphs on there, but just to save a little bit of time, I did the graph of that. So you can tell what the zeros are in this problem. Okay, they are what? -2, +2, and +3, okay? Now what I want to show you how to do is how to, if you know one, how you can get the other two. That's kind of important to me. So let's just pick a 0. So usually like on a test, I give you a 0, and I say find the other ones, okay? All right, so let's just pick a 0. Let's just go with x equals 3, okay? So here's what you're going to do. We're going to do synthetic division. So you're going to take your polynomial. So you have 1, -3, -4, 12. Then you want to divide that by 3. Now, based on the factor theorem, what's the remainder going to end up being? 0, right? Okay, you already know that. So as you're doing this problem, you should expect to get that remainder. Okay, so let's go ahead and do that and see if that does happen. So I bring down the 1, multiply, add the column, and let's see if that works out. Okay, sure enough, it works out. Okay, that's what the graphing calculator is telling us. So what we're left with on this, remember that's the remainder, that's a constant term, that's the x to the first term, that's the x to the second term like that. Okay, so what you would end up having on this is you would end up having x squared minus 4 would be the result like that. Okay, all right, everybody with me there? Now what you're going to do is you're going to take that x squared minus 4 and you're going to set it equal to 0. Okay, when you do that. Now you can solve this equation and you can either solve it by factoring or you can just do this if you want to. Let's just do square root property. That's x squared equals 4. Square root both sides, we have x equals plus minus 2. Does that match my graph? Okay, so see if you know one 0, you can find the other one. So the zeros would end up being just on this one, -2, +2, and 3. Okay, what I have you do for testing purposes is generally I just give you a first 0. Okay, I don't give you a graph or let you use your graphing calculator. I just give you the first one, and then you want to be able to find the other two. Does that make sense to everybody? Okay. All right, so let me show you kind of what would happen on this next one here. All right, well, on this one, I'm going to look at my graph to kind of get the first 0. I'm pretty sure that -3 looks like a 0. So let's just use x equals -3 on this. I also want to kind of, as I do some of these, I want to put some of these in a factored form too, okay? So what you would do with this problem then is you want to go ahead and you want to do your synthetic division. So you would have 8, 18, -17, and 3, and then we're going to divide both sides by -3, all right? And what's the remainder going to be? 0, right? Because we already know it's a 0 just by looking at the graph. So let's see if that works out then. So I bring down the 8, multiply, that's -24, add, that's -6, multiply, that's 18, add, that's 1, multiply, you do get a remainder of 0 like that. Okay, so that proves that. So what you got to do next is you got to understand what's left over. That's a remainder, that's a constant, that's negative, that's an x to the first, and then that's an x to the second like that. Okay, so what we do next is you write down what you're left with. So you write down that you're left with 8x squared minus 6x plus 1, and then you set that to 0 to find the other two zeros. So what'll happen, that's a quadratic equation. Two things could happen. It's either going to factor or it's not going to factor. This one, I might factor. I'm going to try this and see. I'm not sure if it was. So like that first term, you could use like 4x and 2x. That last term, you could use a 1 and 1. So I think this does factor, actually. So that inner term there is 2x. That outer term is 4x. You can make that add up to -6x if you have two negative signs, right? So what you'd end up having is that like that, okay? So once you get that thing factored, then what you're going to do is you're just going to solve these two equations to get your other two zeros. So you would have 4x minus 1 equals 0. And you can do that in your head. Move the 1, divide by 4. So that's x equals a fourth. That would be one of your zeros. And then the other one would be 2x minus 1 equals 0. Move the 1, divide by 2. You would have x equals a half. So actually your zeros are going to be on here. It looks like -3. I got that from the graph. 1/4 and a half. Now getting the 1/4 and a half from the graph is a little hard to do. You want to go with the one that's the most obvious, okay? Now when you put this in a factored form, this is the next thing that you want to see how I do is in this factored form. If you have a 0 of -3, that gives you a factor of x plus 3, right? Because x plus 3 is equal 0 gives you that. Okay, the other ones came from here. So you want to use this form right here. You want to write that as 4x minus 1 times 2x minus 1. So actually, that's how that polynomial is factored. So you can use, if you know a 0, you can use it to factor polynomials too that have a third power and higher. It doesn't work on all of them, but it works on some of them, okay? So again, what you would have is that on your graph, you'd have the -3, the 1/4, and the half. You can't see it because it's so small, but that's where that would go, okay? All right, and notice that one looks like it's kind of hard to tell. I think it probably crosses, but you'll kind of see that touching and crossing behavior on these as you do these, okay? Okay, so let's see. Let's go to the next page. Now, I'm not going to do the P over Q stuff. And what I'm going to do is just kind of take this approach, look at the graph, and then see if we can find a 0 on here. This one I actually may have to do the P over Q, okay? Or actually, let's do this. Let's do this instead. Okay, let's just put this in the calculator and find out. I mean, you could just sort of random, and it looks like they're all at fractional values is what I'm thinking. So I'm going to put this in and just sort of see what goes on here. So I'm going to have 3x to the third, and then I have minus 13x to the second, and let's see, minus 5x, and then plus 3. Okay, I'll just do that in the standard window, so I can see kind of what's going on. Okay, so it looks like these things are going to be at fractional values. Okay, I suspect one of them could be a half. I'm just going to take a guess on that. I don't think that would be the case. I may have to do that P over Q list on that after all. One of them might be something like 2/3. I have a feeling one of them is negative 2/3. I'm going to just try something. I'm going to trace at negative 2/3. That was a bad guess. So I'm going to go ahead and do the P over Q list, okay? All right? I thought I'd be able to maybe just look at that one and tell, but I can't. Okay, so this one you're going to have, you have the P is going to be 3. So that's plus minus 1 plus minus 3. The Q is the same thing, so that's plus minus 1 plus minus 3, okay? So when I put this together, it would go like this. You'd have 1 over 1, 1 over 3. See, a third might be one of them. Okay, then I'll have 3 over 1, which is 3. Okay, then I'll have 3 over 3 again, so I'll get that. So maybe one of them is negative 1/3, or maybe one of them's a third. That's what I'm going to try. Okay, so I'm going to trace at positive 1/3. There we go. That's it. Now see, the P over Q list sometimes will give you a 0. It shows up in one of those numbers sometime. So what we'll start with is we'll just start with 1/3. For testing purposes, like I said, don't worry about that. I'll give you the first 0. Okay, and once you find that, you're going to be okay. All right? Okay, so let's go ahead and do this then. We're going to do synthetic division. So what we're going to do is we have 3, negative 13, negative 5, and 3, and then we're going to divide this by a third. Okay? Now this will be kind of another thing that can happen. I can pretty well predict what's going to happen on this problem. I already know. Okay, so what we'll have on this is that will come down as a 3. A third times 3 is 1. Negative 13 plus 1 is negative 12. A third of negative 12 is negative 4. That's negative 9 when you add. A third of negative 9 is negative 3. So we got 0. Okay, so we know that. I just proved that that's a 0. So what's left over again is that's your remainder. This is your constant. That's your x term. That's your x squared term like that. So what you would have left over is you have 3x squared minus 12x minus 9. And then we're going to set that equal to 0. Okay, now that's a quadratic equation, so we have to solve that quadratic equation to get the other two zeros. Okay, well, does this have a common factor? 3. Let's take a 3 out. Okay, and go ahead and take a 3 out if you want to. So that's 3x squared minus 4x minus 3 equals 0. Okay, now this one won't factor. You can play with the factoring, it isn't going to work. So what do you have to do? Go to the quadratic formula, okay? All right, every now and then you got to do that, okay? So let's go ahead and do that. Now, you don't worry about the 3. So what you do is you can divide by 3. You could have done that at the beginning of the problem. So it's important to take out common factors because it makes the work easier when you go to the quadratic formula. Okay, so let's do that because we're going to have to. So what we'd have is negative b. b is negative 4. Then you would have plus or minus square root of b squared. Okay, so b is negative 4, so it's negative 4 squared minus 4ac all over 2a. Okay, and you got to know the quadratic formula. I won't give you that formula. That's an important formula that people just need to know. Okay, so what it looks like I end up having is 4 plus or minus the square root of 16 plus 12 all over 2 like that. So that gives me 4 plus or minus square root of 28 over 2. I'm glad this is working out this way because this is an area that students struggle with mightily a lot of times. What do you do with the 28? 4 times 7, right? Okay, you want to work that as 4 times 7. So you have 4 plus or minus square root of 4 times square root of 7 over 2. Okay, that becomes 2. So you end up with 4 plus or minus 2 root 7 over 2. Is that done? No, you just split it apart and simplify it. So what you're really doing is 4 over 2 plus or minus 2 root 7 over 2. So that would give you 2 plus or minus root 7. So those are your other two zeros, and that's the only way to find them. Your calculator isn't going to find those roots for you. It would give you the decimal equivalent. So let's write in our answer blank we have 2 minus root 7, and we have 2 plus root 7. And if you go to the quadratic formula, they come in pairs. They come in conjugates. So that happens pretty frequently as you get these conjugates when you do that. Okay. Now notice on that problem there were 3 zeros. The polynomial had a 3rd degree, you get 3 zeros. If the polynomial is a 4th degree, you get 4 zeros. If it's a 100th degree, you get 100 zeros. Don't worry about that. We're not going to mess with that, but that's what theoretically would happen. Okay. So let me show you how you would approach number 6. I wanted to do one that's got a higher power to it. So is everybody okay with what I just did there? Okay, testing purposes, I give you a 0, you find the other 2. And that way you got to do your synthetic division, your factoring, quadratic formula. Okay, so I'm going to take the graph on this one, and I'm going to see if I can find a 0 on this one. It looks like 2 is a 0. And it looks like -1 is a 0. Let's just find out. Let's just do the synthetic division and find out. So let's take the polynomial we have. We don't have any missing terms, so that's 1, 5, -4, -16, -8. And let's divide by 2 and see if it's a 0. Okay, if the remainder is 0, then it's a 0. Okay, so we just bring that down, do that real quick. 1 times 2 is 2. 5 and 2 is 7. 2 times 7 is 14. That's 10. 2 times 10 is 20. That's 4. 2 times 4 is -8. So we have that. So without a doubt, our first 0 is a 2. Okay. Now what you do on this one then is you take this result right here and you do synthetic division again. So what you want to do here is just write down what you're left with. Don't worry about the remainder. That doesn't make any difference. Just 1, 7, 10, and 4. If you look at the graph I put on your paper, it looks to me like -1 is a 0. So what we're going to do is take the result and divide that by -1. Okay, like that. Okay. So if I do that, I just bring down the 1, multiply that's -1. That's 6. Multiply that's -6. Add that's 4, multiply that's -4, so we got 0. Okay, so that does mean that -1 is a 0. Okay, so if it's a 4th power, okay, without your calculator and to keep you from doing trial and error, you really need 2 zeros. Now what you're left with is this. See, that's the remainder, that's the constant term, that's the x term, that's the x to the 2nd term, like that. So what you would end up having on this is you would have x to the 2nd plus 6x plus 4. You would set that equal to 0. Okay, like that. Okay, that doesn't factor, so we'd have to go to the quadratic formula again. Okay, all right, everybody with me there? Okay, now what will happen is I already know I'll get a real number because see, notice this thing crosses 3. It's hard to tell what happens there if that's two times it's touching or what, but we'll find out. So we are going to have 4 zeros. Let's just go ahead and go to the quadratic formula. So we have -b plus or minus b squared minus 4ac all over 2a, like that. So we're going to end up having -6 plus or minus square root of 36 minus 16 all over 2. So that's going to be -6 plus or minus, and that's square root of 20 over 2. What are you going to do with the 20? 4 times 5. Okay, so we need to do that. So we'll end up having -6 plus or minus square root of 4 times 5 all over 2. So that's -6 plus or minus 2 root 5 all over 2. Now you can divide that in your head. That would be 6 over 2 would be -3. 2's cross out, plus or minus 5. So you would end up having -3 minus root 5 is a 0, and -3 plus root 5 is a 0. Yes?
So why did you do -1 with what the remainder was after you said?
Because I want to get it down to a 2nd power.
Oh, okay.
See, if you did the -1 back in the beginning, it would have a remainder of 0,
Right.
but you wouldn't get anywhere. So you want to go there because you're always wanting to just get that down to quadratic, so you use the formulas. Okay. All right. Okay. So let's see, just a couple more things, and I think we're finished up. I think we'll finish this a little early tonight, which is good. Then I'll show you a little bit what I want you to look at on the test over the weekend. So this is real simple. A couple of things is this. A polynomial function is always going to have n zeros. That's what I've been talking about. So if it's x to the 3rd plus, whatever, that's going to have 3 zeros. Okay, if it's f of x equals x to the 6th, and then blah, 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 it's going to have 6 zeros. Okay, it always will, which is kind of fascinating. That's that simple, but sometimes they're complex. Okay, and then we talked about the rational zeros the P over Q. And then this thing right here is just real simple. So how many zeros is this going to have? The maximum number of zeros it's going to have is 5. This one, the maximum number of zeros that's going to have is going to be 4. Okay? And one thing that you can learn about when you're working this section is you can graph on your calculator, and that'll help you kind of see and understand what you're doing. Okay? All right, let me close this off and